Why do physicists say that sine x approximately equals x when x is small? If you're taking physics classes, you'll see this all the time. When you're working around x equals 0, you'll just replace sine of x with x. But why can we do that? Let's examine the function f of x equals sine x and do a linear approximation around x equals 0. So remember that a linear approximation is given by f of a plus f prime of a times the quantity x minus a. So here, since we're taking x to be small, what that means is it's near 0. So we'll let a be 0 here and take our linear approximation based on that. So we have a equals 0. Well, then f of 0 is simply sine of 0, which is 0. So we have 0 here, and here we have x minus 0. So now all we need is f prime of a. Well, f prime of x, since f of x is sine x, the derivative of that is simply cos x. And then f prime of a, which is f prime of 0, is 1. So that gives us a linear approximation of sine x around x equals 0 of 0 plus 1 times x minus 0, which is simply x. So there's sound mathematical footing when physicists use sine x approximately x, as long as x is close to 0, and when you do this in your physics classes, it's totally legit. Let's take a look at the graphs of these two just to see how they look next to each other. Well, here we go. The blue function here is sine of x, and the orange function is y equals x. And notice that around 0, those are almost identical, right? We could zoom in here, and they are very, very much the same, or at least very close. But of course, as we zoom out, as soon as we get away from 0, this would be a horrible approximation. So this only works really close to 0. And when we're close to 0, it's a great approximation.